All right, well, you've found your way to part 2 of ANOVA, so let's get to it. So we are just going to be doing an example this time, and this example is that you're interested in seeing which pet owner is most agreeableness, if any of them are. And we have the following data where we have 5 cat, dog, and horse owners and their score on agreeableness. So, if I could ask you a question like, what are the null and alternative hypotheses? What's the F ratio? And what hypothesis do you reject? So, the hypotheses here, as we've talked about before, that the mean of group 1 is equal to the mean of group 2, which is equal to the mean of group 3. So, the mean for cat owners is equal to the mean of dog owners, is equal to the mean of horse owners. On the other hand, the alternative would be that at least one of those means is different. We can't put the mean of group 1 is not equal to group 2, which is not equal to group 3, because we don't know that. We don't know which combination it is. So if you write it out like this, that's good enough for me. So now let's get to the math. Step 1 in the math, we need to get the total sum of squares. Remember, this is very, very similar to variance that we have calculated previously. So we need to get the grand mean, which is the mean of everyone regardless of their group. And then we're going to take each score, subtract the grand mean, square it, and then with all of those, add them all up. So it really will look a lot like the variance chart. So we have all of our scores, we have the average, and we've taken the score, subtracted the average to get the difference. So x minus grand mean. Then we square it because of order of operations, and we add them all up. And when we do that, we get 46.93. Now, if you were to go ahead and divide by n minus 1, you will end up getting the grand variance, which, because of this little bit of algebra here, we can also get the total sum of squares. And you use that equation primarily when you're given the variance, and you need to figure out sum of squares from there. So in this case, you can also go back and see what happens when you take the variance and multiply it and get 46.93. I don't care which way you do it, though, whatever you're comfortable with. So we have now our equation for the model sum of squares for step 2 of the math. And we'll walk through it first before we get to the actual math itself. So inside the parentheses, we have x bar sub k. Remember, k is group, so it's the mean for your each of your groups separately. So the first one would be 4.2. Then we're going to subtract the grand mean, which we already have from before, 4.27. Then, order of operations, we square that value, and then we multiply it by the number of people in that group. So in this case, 3, 4, and 5. Then we'll do that for each group, and you know that because we have the summation sign, and it goes from 1 up to k, where k is the number of groups. So you'll do it for each of your groups. Start at group 1, then go up through however many groups you have up to k. So for each group you will have one chunk of this information, 1 n sub k times parentheses squared. So let's look at our example. So the first one, the first group mean we have is 4.2 for cats. So we do 4.2 minus the grand mean, which is 4.27. That's what we have in this parenthesis right here. Then we will square that value and multiply it by the number of people in that group, which again is 5. Then we'll do the same thing for our next group, which is dogs. So it'll be 5.4 for the mean of that group minus the same grand mean as before. We have it here, then we'll square it and multiply by the number of people in that group, which again in this case is 5. And then we do that for the third group. We have the mean for the third group minus the grand mean squared times the number of people in your group. Then we just do the algebra. So 4.2 minus 4.27, negative 0.07. Then 5 it's 5.4 minus 4.27, which is 1.13. In these parentheses, 3.12 minus 4.27 is 1.07. Then from there, you'll square the values in the parentheses because of order of operations. That's what we have here, of course, rounding. Then we will multiply the n for each group times that value. So we have done that for each step along the way. And then you just add them together. So the model sum of squares, 12.13. Then the next step we have is the residual sum of squares, and that is just the total sum of squares minus the model sum of squares. So the total that we've calculated in the first step, 46.93, well, we subtract 12.13 from that to get the residual being 34.80. Now, I have it in a slightly different order than the first one because it doesn't matter, as I said there. Now we're going to calculate all the degrees of freedom at one time since the order doesn't matter. So the total degrees of freedom is n minus 1. We have 15, so 15 minus 1 is 14. Degrees of freedom for model is k minus 1. Well, we have 3 groups. Minus 1 is 2. And for the residual, it's just n minus k, which is 15 minus 3 is 12. It's also degrees of freedom total minus model. So 2 and 12 for the numerator and denominator, respectively. Next up, we got to calculate the mean squares. And mean squares are just equal to the sum of squares divided by the degrees of freedom. So for the model, it would be the sum of squares model, 12.13, divided by the degrees of freedom model, which is 2. For the sum of squares residual, it's 34.8 divided by the degrees of freedom residual, which is 12, you get 2.9. And then you just calculate the F ratio, which is the mean square for model divided by that for the residual, which is 2.09. So what can we conclude? Well, in order to know what we can conclude, we have to look at the table. So let's pull up the table. We know that we had the model had 2 and the residual had 12 degrees of freedom. So we find our critical value, which is 3.89. So we can now reject the alternative hypothesis. We know, based on this information at least, that there's a really good chance that these means are not different across groups because our F ratio is less than the critical F value. If we want to write this up in APA style, which I will request that you do, you would say, in this case, we could say something like there was no significant difference between groups. You have to give the F and then the degrees of freedom so people can see what the critical value is. It's equal to 2.09, and because it's the P was greater than 0.05, we would put that information in as well. Therefore, we reject the null hypothesis. We fail to reject the null hypothesis.